An LED backlit LCD display is a flat panel display which uses LED backlighting instead of the cold cathode fluorescent backlighting used by most other LCDs. LED-backlit LCD TVs use the same TFT LCD technologies as CCFL-backlit LCD TVs. Picture quality is primarily based on TFT LCD technology, independent of backlight type. While not an LED display, a television using this display is called an LED by some manufacturers and suppliers. In the UK, the Advertising Standards Authority has made it clear in correspondence that it does not object to the use of the term LED, but requires it to be explained in advertising. Three types of LED may be used: edge-lit LEDs, in which the LEDs are formed around the rim of the screen, using a special diffusion panel to spread the light evenly behind the screen; LED backlighting behind the screen, whose brightness is not controlled individually; dynamic local dimming backlight, LEDs controlled individually to control the level of light color intensity in a given part of the screen. The iPhone 5 has an LED backlit TFT IPS LCD, while the Sony Xperia is an example of an LED backlit TFT TN LCD. Techniques: full array LEDs. Many brands use LED backlighting technology, which offer the advantages over CCFL LCDs of reduced energy consumption, better contrast and brightness, greater color range, more rapid response to changes in scene and more accurate image rendering. Dynamic local dimming LEDs. This method of backlighting allows local dimming of specific areas of darkness on the screen. This type of display comes in white or the more expensive RGB LED configuration. This can show truer blacks, whites, proper color saturation, and photorefractive effects at much higher dynamic contrast ratios by dimming the backlight locally. Comparison with CCFL backlit displays. Compared to CCFL backlit LCDs, LED backlit LCDs produce images with greater dynamic contrast, can be extremely slim thin and edge-lit panels, offer a wider color gamut, produce less environmental pollution on disposal, are less expensive, have longer lifespans, have 20 to 30% lower power consumption, run significantly cooler, are more reliable, allow a wider dimming range, are significantly lighter, often as much as half the total chassis and system weight of a comparable CCFL. Technology: LED backlit LCDs are not self-illuminating. There are several methods of backlighting an LCD panel using LEDs, including the use of either white or RGB LED arrays behind the panel and edge LED lighting. Variations in LED backlighting offer different benefits. The first commercial full-array LED backlit LCD TV was the Sony Qualia 005, which used RGB LED arrays to produce a color gamut about twice that of a conventional CCFL LCD television. This was possible because red, green and blue LEDs have sharp spectral peaks which result in significantly less bleed-through to adjacent color channels. Unwanted bleed-through channels do not whiten the desired color as much, resulting in a larger gamut. RGB LED technology continues to be used on Sony Bravia LCD models. LED backlighting using a LEDs produces a broader spectrum source feeding the individual LCD panel filters, resulting in a more limited display gamut than RGB LEDs at lower cost. A dynamic local dimming LED backlight was first demonstrated by Brightside Technologies in 2003, and later commercially introduced for professional markets. Edge LED lighting was first introduced by Sony in September 2008 on the 40-inch Bravia KLV40ZX1M. Edge LED lighting for LCDs allows thinner housing. The Sony Bravia KLV40ZX1M is 1 cm thick, and others are also extremely thin. LED backlit LCDs have longer life and better energy efficiency than plasma and CCFL LCD TVs. Unlike CCFL backlights, LEDs use no mercury in their manufacture. However, other elements are used in the manufacture of the LED emitters. There is debate over whether they are a better long-term solution to the problem of screen disposal. Because LEDs can be switched on and off faster than CCFLs and can offer a higher light output, it is theoretically possible to offer very high contrast ratios. They can produce deep blacks and high brightness. However, measurements made from pure black and pure white outputs are complicated by the fact that edge LED lighting does not allow these outputs to be reproduced simultaneously on screen. In September 2009, Minco Group announced a joint development agreement with a major Japanese electronics company, under which it will design and develop quantum dots for LED backlights in LCDs. Quantum dots are useful in displays, because they emit light in specific, normal distributions. This can result in a display that more accurately renders colors in the visible spectrum. Other companies are also developing quantum dots for displays. Nanosias, 3M, QD Vision of Lexington, Massachusetts and LG Display of South Korea. Backlight dimming flicker. LED backlights are often dimmed by applying pulse width modulation to the supply current, switching the backlight off and on faster than the eye can perceive. If the dimming pulse frequency is too low or the user is sensitive to flicker, this may cause discomfort and eye strain. This can be tested by a user simply by waving their hand in front of the screen. If it appears to have sharply defined edges as it moves, the backlight is pulsing at a fairly low frequency. If the hand appears blurry, the display either has a continuously illuminated backlight or is operating at a frequency too high to perceive. Flicker can be reduced by setting the display to full brightness, although this degrades image quality and increases power consumption. References. External links, media related to LED backlit LCD television at Wikimedia Commons.